Did you ever try to imagine a world without computers? Today, any computations can be easily made using a laptop computer. But even before that, some computations were indispensable. How would people cope with that? In the 1980s, people would use a pocket calculator. This was then an emerging technology. But even before that, and during most of the 20th century, people would use a slide rule. The first instruments of this type emerged in Britain shortly after 1600. Before they became rules, there were discs. And it was in this shape that the instrument, only just emerged in London, was also introduced to Portugal. Here you can see the earliest form of this type of instrument. And of this type, only 7 instruments survive worldwide. This thin and finely engraved brass disc is perfectly circular. It has 2 rulers attached at the center and joined in a hinge. But these arms are designed to be set precisely on the numbers of the various scales on it. We are going to see how this works. This instrument was called circles of proportion because it shows a number of concentric logarithmically graduated circles, and logarithms combined 2 Greek words to mean proportional numbers. The circles of proportion allow to compute with large numbers. For instance, multiplying huge numbers quickly, extract square roots, cube roots, or elevate any number to the power of 3, 4, 5, etc. Among the many scales, only 1 circle is graduated evenly. The index arms shows its label, E. The circle next to it is labeled N, to designate numbers. And on this scale, the numbers are cleverly spaced, as we will see. As the 2 index arms stand now, they are showing on the N circle 2.2 and 4.6. To each position corresponds also a number on the E circle, 0.342 and 0.662. But when the instrument was at use, the arms could be put to any position. Note that the scale on the N circle doesn't start from 0. It goes from 1 to 10, and this time the graduation is totally uneven. It's logarithmic. That is, the spacing of subsequent values gets smaller and smaller. Let's say today is your 19th birthday and you want to know how many days you've lived since your birth. That's easy. You multiply 19 times 365. Here's what you do. You put the first arm on 1 on the N circle and the second arm on 19. Find 19 by going the scale upwards to 10 and assume that the scale continues from there to 100 when it's your second time going around. So, put your second arm on 1.9 for 19. Now, move both arms without changing the opening, so as to position the first arm on 365, which is represented on the scale as 3.65. The result of the multiplication will appear at the position of the second arm, 6.94. These must be taken as thousands, given that the multiplied numbers were tens and hundreds. So, 6,940 days. The scale is too rough to give the exact amount of days, 6,936. But think that you would here have to add 4 days anyway, one for each bisextile year of your life. Using the end circle, you could also solve more tricky questions. Imagine you have £4,600 in your piggy bank. How much would this amount be worth in 32 years? Suppose it loses 2 1/3% of its worth due to inflation every year. Take the segment 100 to 102 1/3 between the two arms on the end circle and check what this corresponds to on the E circle. It's about 0.1. Now multiply this by 32 for the 32 years. That's easy, it's 3.2. Now open the arms to span 0 to 3.2 on the E circle and move both arms jointly without changing the opening, so that on the end circle your second arm shows now the amount of your fortune, 4,600, represented by 4.6. The first arm now indicates how much worth is left after all these years. £2,200, or not even half of what you had. Well, perhaps it's better not to keep your money in the piggy bank, but spend it on something you enjoy. For those who are into maths, the computation we've just performed corresponds to elevate the ratio 100 to 102 1/3 to the power of 32. And again, the instrument might not yield results to the last digit, but you get an excellent approximation to the correct result. And it's done just in a few gestures. There are several other scales on the same instrument. They contain the values of the trigonometric sine and tangent functions, labeled S and T. This was extremely important at the time, as the most frequent computations in astronomy and navigation implied multiplications and divisions of sines and tangents. The instrument would reduce these operations to a mere ballet of fingers, scales, and index arms. The circles of proportion instrument included further scales. These had to do with astronomy and time telling. Here you see a calendar scale with the indication of a series of bright stars. The scale allows you to tell the time by night. On the back there is a further instrument. Its shape is that of an horizontal sundial, with scales that contain a lot of information about the position of the sun for any day of the year. The sundial was made for a specific geographic latitude, 54.5 degrees north, corresponding to Newcastle in northern England. And this tells us something about the origin of this object. This particular instrument was most certainly made for someone from Newcastle. The sundial would only work for that latitude. An expert can tell from its manufacturing style that it was made at a specific workshop in London, that of Elias Allen, around 1630, where most of the 7 preserved instruments of this type come from. These circles of proportion were not only complex, but also rather costly objects. Only wealthy and mathematically educated persons would want them. A lot of labor went into their production, and brass was an expensive material. Due to these factors combined, the circles have never been produced in large numbers. Nevertheless, The maker, Elias Allen, produced several of these instruments. One made by Allen's apprentice, Richard Davenport, is also preserved. The emergence of the circles of proportion was surrounded by controversy. The instrument's inventor was William Oughtred, a mathematics teacher who lived near London. He discussed the idea of the instrument with the instrument maker Allen. Another mathematical practitioner saw the design in Allen's workshop and rushed to publish the invention in print with a royal patent under his name, Richard Delamain. This ambitious man also gave a particular and fancy name to the instrument, grammalogia. Later, the true inventor student, a certain William Forster, published the original version of the instrument in 1632 with instructions for its use. The book included a violent attack on Delamain for having stolen the idea of the instrument. Just a few years after these events, the instrument became known in Lisbon. A mathematics teacher who lectured at the Jesuit College of Lisbon would write a treatise on logarithms and another one on various types of arithmetical instruments, among them the circles of proportion, which he called, irony of fate, grammalogia. The name of this remarkable Jesuit is Ignace Stafford. He was born in England. His treatise is dated 1638, just 6 years after Forster's had published his. Stafford's career in Portugal during the unified Spanish-Portuguese crown was steep. He became even confessor of the Viceroy of Brazil, the Marquis of Montalvão. Was it through Stafford, then, that this particular exemplar of the instrument came to Portugal? We know that after Stafford's death, in 1642, a dispute erupted about who could inherit the instruments he had left behind. Whether the circles were among them, we do not know. What we know is that 3 centuries later, after the abolition of monarchy in Portugal, when the furniture of the Royal Ajuda Palace was inventoried in 1912, this instrument was among the precious instruments kept in a box. From the former royal collections, these circles passed then into public ownership of the Portuguese Republic. In the 1950s, the then director of the Ajuda Palace, without exactly knowing what these instruments were, passed many of them to a secondary school. In 1992, the circles were finally given in deposit at the Munich, where in 1999 the eminent instrument connoisseur Gerard Turner identified the instrument as one of the exceedingly rare circles of proportion.